The next item that we had to cut was item P4. P4 is the guide plate, and this plate pretty much keeps everything lined up. The pies coming out, the leaves coming out, the star coming up correctly. So it's a pretty important piece, and I wanted it to be perfect. Now the problem is, and this is the first time I ran into metric versus, I guess it's called imperial or U.S. measurements, and it calls for a 1600 by 1600 sheet to cut this guide plate out of. And I bought 2 or 3 sheets of 5x5 Baltic birch, thinking that 5x5 would be enough. Well, it wasn't enough, and it then became an issue for me in regards to what was I going to do. And so essentially I kind of had to use 4 different pieces to make it work. Let me show you what I did. So I took the first sheet, I took 2 4x8 sheets of Baltic birch, and I cut it down to 1600 millimeters in width by the 48 inches. And that essentially comes down to 1600 by 1219.2 millimeters to be exact. So I got that cut, and this is a perfect 16 by 1600 piece of workpiece. And so essentially what I did is I took this and I put this piece in place just like that. So that covered the major portion. Now the problem was I still have this portion here that was empty. So I took another sheet identical to this one, which would be this one, same size, and I moved it here. In actuality, I put this one down first, the one that's vertical, and then I put the horizontal one on top of it, so that I had 1600 this way and 1600 this way. Obviously, I had an 1800 millimeter drop at this line. So essentially what I did is I tacked with 4 composite nails, just a nail here, a nail here, a nail here, and a nail here. I used composite nails for fear of having a problem with the CNC cutting into it, and composite nails work great. So the next thing that I did was I figured the difference. I knew that this was going to be 1600 millimeters, but the question is how high did it have to be? And it ended up being 380.8 millimeters to make a flat piece on top that was 1600 by 1600. Oops, sorry, my bad. There we go. And so I cut that piece and I put it in place. And now, as the worksheet shows, I have a piece that is 1600 by 1600 on the top. And I put 2 small composite nails here on top. I didn't take time to put this piece in at this point because I really didn't need to. And that one is obviously going to go here to make the bottom the same size. And I'll put it in place just to show you that's where it ended up. So with that in place, I had a full 1600 by 1600 piece of wood. But the problem is it's 2 sheets thick, 18 millimeter sheets thick. So this piece is 36 millimeters thick. So I had to somehow do a 1600 by 1600 glue up with the 4 pieces. And the easiest way for me to do it was to use, there's 200 screws in this plate, these little black knobs, and I just decided to use the screws. I already had the composites in place. I had a square bit. So essentially I just went up to the layers and I turned all the layers off except for the holes. So this is my sheet that I have now, and I have all the holes. And so essentially all the holes are in place. I simply selected all the holes, and I have this worksheet centered precisely to make it easy for me to find these holes, so that once I got them in place, I wouldn't have to worry about cutting the slots and hitting a screw. So essentially I just went here and I aligned all the screws to the center, as you can see here. So they're all right there. All 200 screws are in the exact place they're supposed to be on this 1600 by 1600 piece of plywood. So essentially I went to the tool path. I used a profile tool path. Some would use something else or drill holes. I just like doing it this way. It's easier for me. And I'm just going to change this so you can see that it went through. And I used an end mill, which was a 1/8 inch end mill. It's 3.175 millimeter is 1/8. So I used a 1/8 inch end mill. I did it inside, and I calculated it. Okay, so there they are. They're hard to see, but there's all little dots. And this is just the path that the CNC is going to take to get there. But if I go over and I cut it, it shows all the holes, as you can see. So all 200 holes are in place at this point. So essentially, if I went back to my 2D view, and all the holes are now cut in the top portion, the top layer of 18 millimeter Baltic birch, I then went in and separated them. I just pulled them apart where I had 2 nails here and 4 nails here. So it was essentially 6 composite nails that I removed. And then I glued it all up. I got all the glue. I rolled it on both sides. And then I put it on top where they lined up and kind of got a clamp across on this side and this side. And then I started screwing it all down. And I screwed all 200 screws down so that it was very, very strong. And it worked out really fairly nicely and gave me a sheet of 1600 by 1600 to be able to cut the slots and the bearing slots out with. So once I got the clamps off and it was dry after 24 hours, it was time to cut the entire guide plate out. And again, I was fairly confident I wasn't going to have any problem with the slots because I knew the screws were where they were supposed to be. Essentially, I went back and turned on all of the layers that were on the guide plate, and I selected the whole thing, and I put it in place. So once I got all of the layers copied into the center of the worksheet, it was time to choose the stuff that I had to cut. Since I already have the holes in place, I turned those off, and I just kept the three items that had to be cut, which were the slots, the outside boundary with the bearing cuts, and the inside circle. So I chose all of them because it's just easier that way, and I deselected the outside boundary. And I deselected the outside boundary because they're all outside cuts. It's all on the outside. I also deselected the bearing bend over supports because it's part of the bearing cut. So essentially, I wanted anything that I was cutting on the inside of the line in place. And I went to the tool paths, and I did a profile tool path, and I went 36 millimeters deep, going through two sheets. A 6.35 millimeter end mill is what I'm using, which is /a quarter-inch end mill. And I went on the inside cut because I'm cutting on the inside of each one of these lines. And then I calculated it. And as you can see, they're all there. And I'll cut on the inside. And if I wanted to, I could just preview the selected tool paths, hit the button, and it shows you that all my holes are in place, and the slots are all in place. Essentially, I can get rid of all of them just by double clicking on each piece that's been cut out. If I was better with my mouse, I wouldn't make mistakes. Come on, Ed, wake up, big boy. There you go. Okay, so there we are with all the inside cuts done and all the holes done. So essentially what that left us now was the outside cut and the bearing pieces, which is this one right here. So essentially I click off of this, and I click this and include all of the supports. Oh, Ed. Come on, you can do this. You select all the supports because these are all an outside cut. They're cutting on the outside of the line. And then I went to tool paths. And I chose, again, a profile tool path. And this time I'm cutting on the outside of the line. And again, I'm going 36 millimeters. I'm doing 6.35 millimeters in the way of a bit, which is a quarter-inch. Outside right, and I calculated. And as you can see, there it is. It's calculated and it's in place. And I cut it. And now it's ready to go to the CNC machine. The cuts, we didn't decide to do this video until after I had cut this and the next one, which is the bearing block. But as you can see, it's a very large piece, and it cut quite nicely. You can see the seam where we did the lower portion and the top portion that went across. You also in this picture can see where the bearing mechanism slides into with the bent over support bracket. And this image just shows you the number of screws that were involved in close proximity, and then of course the thickness of the cut itself. Thanks for watching. See you next time.